Okay, so welcome to this video. We are now looking at test one. Okay, so test one has two questions. There's question one, which is on sets, rational numbers and SURDS. Okay, so that's the question that we're going to solve in this video. And then in the next video, we're going to look at question two, which has binary operations, functions, and then quadratic equations there. Okay, so we start from question one, which has definitions. So the first one here, they're saying define the following terms. Or number one, they're saying an equality of two sets. Okay, so this is the definition. You're going to say two sets, okay, two sets A and B are said to be equal, okay, written as A is equals to B if and only if, okay, they have the same exact elements, okay, the same exact or equal elements. Okay, so the equality of set happens when, okay, this happens when set A is a subset of set B and set B is a subset of set A. So simply meaning like if, for example, A has 1, 2, 3, okay, and then B also has 1, 2, 3. So this is the only way two sets can be equal, is when they contain the exact same elements, okay, and they are subsets of each other. Then we are going to say those two sets are equal. So if you want, you can screenshot this, but make sure you memorize it. It can come as a definition in the exam or tests. And then the other one, they are saying we define a cardinality of a set. Okay, so I'm going to say cardinality here of a set, okay, is the number, okay, is the number of elements in a given set. Okay, that's the cardinality of a set. It's just the number of elements in a given set. So we are done with these definitions. I move to B. They're saying write this set A is equals to 1, 4, 9, 6, 25, 36, and so on and so forth, okay, in set builder notation. So the way it has been given here, this is what we call as the roster form or the listing form. So we want to change now this set into the roster form, the set builder notation, I mean. So we have to express this set, okay, in terms of a description of what it contains. So what we notice here is that this set A, this guy is the same as 1 to the power 2. This 4 is the same as 2 to the power 2. This 9 is the same as 3 to the power 2. This is 4 to the power 2. This is 5 to the power 2. This is 6 to the power 2. So it meaning that the next term here will just be like 7 to the power 2, 8 to the power 2, and so on and so forth, right? So here we just notice that they are squaring numbers starting at 1 and then increasing like that. So numbers that start at 1 and then they start increasing are called natural numbers. Okay, so those numbers belong to the set of natural numbers. So the set of natural numbers starts at 1, 2, 3, then it increases to infinity like that. Okay, so to describe this in set builder notation, I'm just going to say set A, okay, is a set of all x's such that x is equals to n squared, okay, where this n is a member of the natural numbers. Okay, so this description here, it gives us the idea of what elements should appear here, of which those elements will just be these guys that I've written these guys that we are given on top there. Okay, so this is the roster form. This is the set builder notation. Right, what about the other one? So the other one will be doing the opposite. They're saying this set has been given in set builder. They want us to write it in roster. So roster is just the listing. So they've said set B is a set of all x's such that x is equals to 2n plus 1 over n plus 2, where this n is a natural number, okay? It's a natural number and the n is less than 7, okay? So meaning we're just considering which natural numbers, 1, 2, 3, 4, 5, 6, because the n is less than 7. So set B will just be equals to, if we list it, the first element will be when the n is equals to 1. So that will be 2, 1 plus 1 over 1 plus 2. Then we go to 2 plus 1 over 2 plus 2, comma, 2, we go to 3 plus 1 over 3 plus 2, 2, 4 plus 1 over 4 plus 2, and then we go to 2, 5 plus 1 divided by 5 plus 2. And the last one will be 2 when the x is what? When the n is 6, since n is less than 7 here. So it will be 6 plus 1 over 6 plus 2. Okay, so we just have to simplify whatever we've been given there. Okay, so this one, it will be 2 plus 1, which is 3, 1 plus 1, which is 3. So this is 3 divided by 3. So I just get 1, comma. This one, on top I have 2 there. 2 multiplied by 2 is 2 plus 1, 5. 5 divided by 4. So that is 5 divided by 4, comma. Here I have 6 plus 1, that is 7 over 5, comma. Here I have 8 plus 1, 9, down 6. Okay, comma. Here I have 10 plus 1, 11 over 7. And then the last one is just 13 over 8. Okay, so this is the set when we list its element. Right, so we're done with that. We move on to C. So C, they're saying let the universal set be U. Let the universal set U be the numbers 1 all the way up to 20. Okay, given that set A, so they've given set A in terms of a set builder notation. So they're saying set A is a set of all x's such that x is equals to 2k, where this n, okay, is a part of the natural numbers. Okay, so x is equals to 2k, okay, where the k, the n is, the x is a member of the natural numbers. Okay, so there must have been some typing error there. So this one here is the one that is supposed to be k. So it's telling us that the k is the natural number. Okay, and then now using this formula 2k, we can find the values of x, okay, that are within this set here. So I'll say the first one is when the k is 1. Remember, the set of natural numbers, okay, starts from 1, 2, 3, 4, 5, 6, and so on and so forth. So the first element to be in set A will be when k is equals to 1. Okay, when k is equals to 1, the first element will just be 2. When k is equals to 2, it will be 4. When k is equals to 3, 6. When k is equals to 4, to be 8. When k is equals to 5, to be 10. When k is equals to 6, that is 12. When it's 7, is 14. When it's 8, is 16. When it's 9, it's 18. And when the k is 10, I'm going to have 20. When the k is 11, I'm going to have 22. But the universal just ends at 20 there. So we can't put the 22 there. So we end there, okay? Because the universal set starts from 1 to 20. And then set B has been given here as 5, 7, 9, 11, 13, 15, 17, 19. Okay, that's what we have there. So now C has also been given as this set 1, 2, 6, 8, 9, 11, 15. This is my set C. So the first thing that I want to find is A union B complement intersection C. Okay, so first of all, to find the A union B complement, okay, we have to find A union B. So what is A union B without the complement? So I'm just combining all the elements in A and all the elements in B without repeating any. So I get 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so it's just all the numbers apart from 1. Okay, they're the ones that are making up A union B. Because if I combine these two sets, I get all this here. So it means A union B complement will just be the universal set. I remove all these numbers, but the universal set is from 1 to 20, and then 2 to 20 are in the A union B. So it means in the complement, I'll just have 1. Okay, and then now to do A union B complement, which only has the member 1, I intersect this with this C, which has 1, 2, 3. So what will be common there between this set and this set? What is common there is just the element what? 1, or the member. Okay, so I've missed it. Sorry for that. I've missed 3. Okay, so 3 is not also in this A union B. So I've missed 3. So here in the complement, I have 1 and 3 because I can't see 3 here, okay, or anywhere there. So it means now A union B complement intersection C, it will be what? Okay, A union B complement intersection C is still going to be 1 here because between this set and that set for the C, only 1 is common. Okay, so the first one, the answer is this guy. And then the other one, they're saying A intersection uh, A intersection B complement. Okay, so A intersection B complement, we're going to be very clever on how we're going to find it. So remember the De Morgan's laws. If I have A union B and then complement, this is the same as A complement, okay, intersection B complement. But I already have this. I found it was 1, 3. So this guy is just 1, 3. And you're done. Okay, so if you don't know the De Morgan's law, you start again finding the complement of A, complement of B, and then you find the intersection, which will be wasting time. So it's better you know the tomorrows. Okay? Yeah. So that is the answer there. Okay. We move to part D, where we want to express this in form of a fraction. So I'll say let x be equals to 2.001 bar. So this bar on top means 1 keeps on repeating. So the other way to write this number is 2.00111111111 until Jesus comes. You will still be writing because it's continuously repeating. Okay, so mathematicians are smart people. They found a notation, okay, to represent something that keeps on repeating forever. So they just put a bar on top, meaning that it repeats. So whenever we are changing, okay, a decimal number that is repeating to a fraction in the form P over Q, we just have to get 2 numbers from this given number, okay, that have the repeating part immediately after the decimal place. Okay, so the decimal point is there. So the first number, I want to move this decimal place 2 times. Okay, so if I move it 2 times, it's the same as I multiply this side by 100. So I have 100x is equals to, and then 100 multiplied by 2.001 bar. So if I multiply by 100 this guy, it becomes 200.1 bar. So this is the first number. And then I get the second number. So the second number, because remember, this part here is the same as 200.111111. So I just want to move this decimal place one more time so that I have two numbers such that immediately after the decimal point, I have the repeating part. So how can I do that? Okay, to move the decimal place one time, I have to multiply this part by 10. So I also multiply that part by 10. So it will be 10 multiplied by the 100x is equals to 10 multiplied by the 200.1 bar. So this will just give me 2000. Okay. No. Yeah. Okay. Anyway, it will give me 2000 and then 1 and then 0.1 bar. So I've just moved this decimal place, this point. This part is still repeating. It's this part that I'm representing as a bar. Okay. So if I multiply this, I get 1000x. Okay. So I have my two numbers such that immediately after the decimal place, I have the repeating part. Okay. I have this 100x. Let me write it here. I have the 100x is equals to 200.1 bar. And then I have the 1000x is equals to 2001.1 bar. So once I get those two numbers, then I'm done converting my decimal number to fraction, because here I'm just going to subtract. So it will be 1000x is equals to 2001.1 bar. Then I subtract this guy, the 100. Okay. I subtract the 100x is equals to, that is 200.1 bar. So the whole purpose of us finding these two numbers is that once we subtract them, the repeating part there should cancel out. So you see we have 1 bar after the decimal point. So there it's going to cancel out. So that will just be 0. Okay. So now here I have a 1000 minus 100. So I get 900x is equals to. Then here I have 2001 minus 200. That will give me 1801. Okay. So remember we had said our x is equals to 2.001 bar. So here we find our x to be 1801 over 900. So is there any two numbers that can go into this number and this number without leaving a remainder? No. Okay. So this guy in a fraction is the same as 1801 over 900. And we're done. Okay. I go to 2, where we're rationalizing the denominator. So we're rationalizing 2 root 5 minus 3 root 5 over 3 root 3 plus 3 root 5. So to rationalize the denominator is to remove these square roots from the denominator. Okay. So how are we going to remove them? We're going to multiply by a special one. So that special one, okay, it's a 1, but we're going to express it in terms of some other complicated stuff. So to rationalize the denominator, we just have to multiply by what we call as the conjugate. So the conjugate is the same thing that you have in the denominator, but you just put the opposite sign on the middle. So if I have a plus, it means in the conjugate, I'm going to have a negative. If I have a negative there in the conjugate, I'm going to have a positive. So I'm multiplying both the numerator and the denominator by root of 3 minus 3 root of 5. And then root of 3 minus 3 root of 5. So let us expand. Okay, let us expand. So we're going to get 2 multiplied by root of 3. 2 root of 5 multiplied by 2 root of 3. So remember, if I have root of A multiplied by the root of B, this is the same as 1 root, and then I multiply A and B. So I get AB. So that's what is going to happen here. Okay, I have root of 5, root of 3, and then the 2 in front. So it will be 2, and then 1 root, and then I multiply 5 and 3. So that will be 15. Okay, and then now I say 2 root of 5 multiplied by minus 3 root of 5. So that will be minus 6. I multiply 2 and 3, and then root of 5, where is it? Root of 5 and root of 5 just gives me a 5. Okay, because it will be root of 5 multiplied by the root of 5, which by this rule is the same as root of 5, and then 5 multiplied by 5, that is 25. Square root of 25, just 5. This is the 5 that I got. And then now I've finished multiplying this with everything that I have here. Now I multiply this part with everything that I have there. So it will be minus 3 root of 5 multiplied by root of 3. I get minus 3 root of 15, because 5 and 3. And then minus root of 3, minus 3 root of 5 multiplied by minus 3 root of 5. I get plus 9 from the minus 3 and minus 3. And then from the root of 5 and the root of 5, I get 5. Okay, and then divided by. So now these two are conjugates of each other. So whenever you have conjugates of each other, you just square the first term, and then you say minus square the second term. So it will be root of 3 squared minus the second term is 3 root of 5 squared as well. Okay, so this is just going to be equals to 2 root of 15 minus 30 minus 3 root of 15 plus 45 divided by 3 minus, here, this squared goes to the 3, becomes 9. Then the squared to the root of 5 becomes 5. So that is 9 multiplied by 5, which is what? 45. Okay, so we're going to have 2 root of 15 and minus 3 root of 15. We can combine those. Okay, we get minus 1 root of 15, and then minus 30 plus the 45, I get plus 15. And then down there, what am I going to get? 3 minus 45, that will be minus 42. So it means we have rationalized the denominator. And we're done. All right, then let's look at part E, okay, which is the last question on question 1. So part E, they're saying simplify and express 1 over root of 12 plus 1 over root of 48 minus 1 over root of 27 in the form P root of 3. Okay, so that should be an eye-opener. So whatever number has a root here, okay, I want to make it to have a root of 3 somehow. So remember, if I have root of A multiplied by B, this is the same as root of A multiplied by the root of what? B. Okay, in fact, before I separate them, it will be, it will be like this, and then I separate them as A multiplied by the root of B. So that's what will happen to this 12. So root of 12 is equals to 12, I know, okay, it's 4 multiplied by 3. So it will be root of 4 multiplied by the root of what? 3. Root of 4 is 2. Root of what? 3. So where there's 12, I put 2 root of 3. Plus, we go to the root of 48. We want to express it as a 3 multiplied by something. So 48 is the same as 16 multiplied by 3. So this will be root of 16 multiplied by the root of 3. Root of 16 is 4, and then I have root of 3. So here it will be 1 over this root of 48. It's 4 root of what? 3. Okay, and then the last one, the 27 there, it's if I have root of 27, that is the same as 9 multiplied by 3. So it will be root of 9 multiplied by the root of 3. That will just be 3 root of 3. So you've seen I've expressed all my numbers in terms of a root of 3, because I can see root of 3 in the thing that they want me to express this form into. Okay, and then from there, what do we do? Okay, we just find the common denominator where all these things can enter. So it will just be 12 root of 3. So 2 root of 3 into 12 root of 3, I get 6. Okay, because it will be 12 root of 3 divided by 2 root of 3. The root of 3 cancels out. This there is 6. 6 multiplied by 1, I get 6 plus 4 root of 3 into 12 root of 3, I will just get 3. So that would be 3 multiplied by 1, I get plus 3 minus 3 root of 3 into 12 root of 3. I get 4. 4 multiplied by this, okay, just get 4. So this is 9, okay, because 6 plus 3 is 9, minus 4, that will be 5, okay, over 12 root of what? 3. But here they said this thing, I should express it in p root of 3, not the root of 3 being in the denominator. So from there, I'm just going to rationalize the denominator. Okay, so how do you rationalize a denominator that has one root? You just multiply by that same root. That's its conjugate. Okay, so on top, I have 5 root of 3 divided by, down, I'm going to have 12. And then this root of 3 and root of 3, they're going to give me a 3. Okay, so simply meaning I have 5 root of 3, 12 multiplied by 3 is 36. Okay, so this guy here is in this form where the p is equals to 5 over 36. Okay, and then my root of 3 is just root of 3. Okay, so that's how we solve those questions there. Okay, that's how we solve those questions there. Okay, so thank you so much for watching this video. This was just part 1 or question 1 of test 1. Okay, so test 2, the video will be available on our website or on our mobile app. Okay, so you can access it on our website, which is Discrete Learning Institute. All right, so when you go on our website, you will see something like this. Okay, so you can enroll for this course math if you are finding challenges with your math, or if you are finding challenges with chemistry, you can still enroll for chemistry. If it's physics, you enroll for physics. If biology, you enroll for biology. Okay, so here I'm just going to show you some of the contents that we have under the mathematics course. Okay, so first semester, you go in this folder. Second semester, you go there. Okay, so first semester, you go in general mathematics, and then you go to the past papers. Okay, in the past papers, you're going to find different university. You select your university, and then you go to the video solutions. So in the video solutions, you can see here we have quite some number of past papers. So past test quizzes and exam papers. Okay, they are here. They are all waiting for you. Okay, so that we can help you pass. Okay, so for this intake, you can see the quiz 2 is there. The test 1 for the ODL guys is there. Your test 2 is there. And then the one that we were doing right now is the test 1. Okay, so the full video will be uploaded here and you can access it anytime, anywhere, plus all these other videos here as you're preparing for your exam. Okay, if you want, you can also check out the tutorial sheets. Okay, so we have videos for all the tutorial sheets. Okay, so let me just show you the folder for the tutorial sheets. Okay, so you open the folder for the tutorial sheets here, and then you go to Apex. Then you go to the 2025 July intake. Of course, we also have tutorial sheets for all the other intakes. So you can see tutorial sheet 1, full videos are there. Tutorial sheet 2, full videos. Tutorial sheet 3, full videos. Tutorial sheet 4, full videos. So we solved all the questions. Okay, so you can be learning at your own time, at your own pace. Okay, so be sure to visit our website, which is just Discrete. Okay, Discrete, there's E there, and then learning.com. That's where you're going to find all these things that I'm showing you here. Okay, and also we've put a link in the description here. Okay, that gives you the link to the website, the link to the app, because we have our mobile app, and on the mobile app, you can actually download the videos and watch them offline. Okay, even in your blankets, as well as a video registration guide. In case you don't know how to create an account, we've made that video available. You can watch it and then register and make sure you pass your exams. All right, so thank you so much. Until next time.